These seemingly disparate concepts are actually deeply interconnected.
Let's start with the math-off protocol. What exactly are we looking at here?
Well, according to recent research from MathDoc, it's a groundbreaking approach to mathematical verification in AI systems. The protocol essentially creates a structured way to extract and validate mathematical truths.
And this is different from traditional verification methods?
Completely different. The research shows it can achieve up to 65% accuracy in truth verification, compared to traditional methods that hover around 32%.
That's a huge improvement.
And here's where it gets really interesting. It uses what's called inference time intervention, or ITI, to enhance truthfulness in mathematical operations.
Can you break that down for us?
Think of it like a velocity profile in fluid dynamics. Just as fluid flow has different layers and speeds, ITI works by shifting model activations across different attention heads.
That's a fascinating metaphor. Speaking of which, let's talk about these velocity profiles.
Right, so in fluid dynamics, velocity profiles show us how fluid moves at different distances from a boundary. It's actually a perfect metaphor for how truth propagates through an AI system.
How so?
Just as fluid velocity changes predictably in layers, truth in AI systems also follows certain patterns. The research shows these patterns can be mapped and measured.
And this connects to the Dominion 10x mode somehow?
Exactly. Dominion's 10x mode is actually a fascinating implementation of these concepts in a game environment.
Tell us more about that.
Well, according to the research from UC Berkeley, Dominion serves as a perfect testbed for these concepts because it requires constant adaptation to changing conditions.
Kind of like how fluid flow adapts to changing conditions?
Precisely. And in 10x mode, it's processing these adaptations at 10 times the normal rate, creating a sort of accelerated truth verification system.
That's incredible. But how does this all come together in practice?
The key is in how these systems handle uncertainty. Just like turbulent flow in a pipe, truth in AI systems isn't always laminar or predictable.
So we need systems that can handle that turbulence?
Exactly. The Markov protocol, combined with velocity profile analysis, gives us a framework for managing that uncertainty.
And what about real-world applications? Where are we seeing this being used?
One fascinating application is in automated mathematical proof verification. The system can detect errors with much higher accuracy than traditional methods.
That's huge for academic research.
And it goes beyond academia. These principles are being applied to financial modeling, scientific computing, even autonomous vehicle navigation.
Wait, autonomous vehicles? How does that work?
Think about it. An autonomous vehicle needs to constantly verify its understanding of the environment. The velocity profile approach helps it validate its perceptions in real time.
That's fascinating. And the math-off protocol plays a role there too?
Yes, it provides the mathematical framework for validating these real-time calculations.
I'm seeing a pattern here. It's all about validation and verification.
Exactly. And what's really exciting is how these systems learn from their verification processes.
Can you elaborate on that?
Well, just like how turbulent flow eventually stabilizes into patterns, these systems develop more efficient verification methods over time.
That's incredible. And this is all happening in real time?
Yes, and that's where the Dominion 10x mode really shines. It's showing us how these systems can operate at accelerated speeds while maintaining accuracy.
Let's talk about the future implications of this technology.
The research suggests we're moving towards systems that can verify truth claims with near-human accuracy, but at machine speeds.
That could be revolutionary for fields like scientific research.
Absolutely. Imagine being able to validate complex math